Blockchain platforms. Module 2. Permissionless blockchain platforms. The Bitcoin network. Permissionless platforms. In this module, we look at permissionless blockchains, focusing on Bitcoin. The Bitcoin network. In this module, we look at permissionless blockchains, focusing on Bitcoin. Let's focus on the inners of the blockchain platform. Architecture and functionalities of Bitcoin. The Bitcoin architecture relies on a peer-to-peer network, which uses blockchain technology as a public ledger to record the financial transactions. Bitcoin resorts to the transaction and unspent transaction output, UTXO, as we see next. Other fundamental elements of the Bitcoin network include mining operations, which yield the creation of new blocks added to the blockchain, all assisted by cryptographic security such as SHA-256 message digest and digital signatures. Bitcoin UTXO transaction flow. Let's take a closer look at the transaction flow of Bitcoin. That is what happens where there is a Bitcoin transaction. Let's consider that Alice has previously received 1 Bitcoin and now needs to pay an amount of 0.75 Bitcoins to Bob. So, Alice sends 0.75 Bitcoins to Bob, creating 2 new unspent transaction output, UTXO, a 0.75 UTXO that will go to Bob, and the change of the 1 Bitcoin, that is 0.25 Bitcoin. So after the transaction is complete, there are 2 UTXO, 0.75 Bitcoins to Bob and 0.25 back to Alice. Note that Alice needs to use her private key to sign, thus authorizing the transaction. The authorization can be verified by any peer of the network, resorting to Alice's public key. Bitcoin unspent transaction output. The main key features of the so-called unspent transaction output, UTXO for short, are as follows. Traceability, since all transactions can be traced back. Security, as this prevents double spending, that is the possibility of a given amount being spent more than once. And efficiency, as it enables parallel transaction processing. Exploring proof of work, POW. The consensus algorithm of the Bitcoin network is the so-called proof of work, OPOW for short. Basically, some nodes of the network, called miners, are continuously attempting to solve a cryptographic puzzle. The one who solves the puzzle, that is, who successfully mines a block, is entitled to have the mined block appended to Bitcoin's blockchain. As we shall see, the appended block contains valid Bitcoin transactions. Thus, the work provided by miners is essential to ensure the security of the network. Alas, solving a Bitcoin's cryptographic puzzle is highly computationally demanding and hence energy intense. This strains resources and can cause environmental concerns. Other limitations are lack of scalability due to the small size of Bitcoin's blocks and slow speed in having transaction accepted, that is, appended to the blockchain. Bitcoin's cryptographic puzzle, proof of work, mining, solving the cryptographic puzzle. In Bitcoins, so-called miners compete to solve a mathematical puzzle. This involves finding a specific hash value for a block that holds Bitcoin transactions. The solving is done through brute force computing, requiring significant computational power. The first miner to solve the puzzle adds the block to the blockchain and earns a reward, new Bitcoins. a Bitcoin mining device. The photo shows a mining device specifically engineered to mine Bitcoins. Its computing power is measured in terahash per second. That is the number of SHA-256 message digest it can compute per second, as SHA-256 is fundamental in Bitcoin mining. The device shown can process up to 335,000 million of SHA-256 per second and requires up to 5,360 watt, being water-cooled. Bitcoin's puzzle explained. How does Bitcoin puzzle work? There are several steps in the mining attempt of a Bitcoin block by a miner. First, each miner creates a block with Bitcoin transactions. Then, it consecutively tries different combination of a numerical value called nonce until it finds a result that fits the so-called network difficulty. Basically, applying the SHA-256 message digest to the block plus the nonce should yield a result with a certain amount of leading zeros. This is repeated until a miner finds an appropriate block and broadcasts it through the network. The number of zeros is called the network difficulty, and it is automatically adjusted every 2,100 blocks, approximately 10 days, by the Bitcoin network. The goal is to maintain a consistent block creation rate of a mined block every 10 minutes. Bitcoin difficulty, T hash per second. The plot displays the evolution of the Bitcoin network difficulties since its inception in 2009. One can see that the difficulty has grown substantially over the years. This explains why Bitcoin mining nowadays requires specific and powerful mining hardware. Thank you for your attention.